Those are some of the tools you'll want to have at your service to be effective on the job. Now, on to the process. The proper process for repairing an HVAC system is recover, repair, check for leaks, pull the vacuum, and then charge the system. With recovery, repair, and a leak check finished, and necessary tools on hand, you're ready to safely evacuate. Before starting, fill the vacuum pump with vacuum oil. Remove the cap, open the fitting, and begin pouring. Keep pouring the oil until the oil level reaches the oil line. Here, you'll benefit from a large oil fill port and the convenience of a large sight glass, which gives you the benefit of being able to see when the oil reaches the appropriate level. It's important to note here that the quality of your vacuum pump performance is directly related to the quality of your vacuum pump oil. The cleaner your oil, the better your pump's performance. Another important fact to mention here is that a quality two-stage pump will work with any refrigerant. It's recommended that a high vacuum mineral-based oil be used in all pumps, regardless of the type of oil that is used in the system. Now, back to the process. Once you can see through your sight glass that you've reached the proper oil level, put the fittings back on, or, if desired, attach the exhaust filter. Remove the Schrader cores if present with the core removal tools. Install the test and charging manifold. For this demonstration, we're using a 4-valve manifold. Connect the hoses from the manifold to the system. For demonstration, we're using 3/8" hoses for a faster and deeper vacuum. Connect the low side or blue hose to the low side core removal tool and high side or red hose to the high side core removal tool. Connect the 3/8" hose from the vacuum port on your manifold to the 3/8" port on the vacuum pump. Connect the 4th hose from the manifold to the refrigerant cylinder. If you're using an exchange for your pump, plug in the power cord for the pump. Now, open all manifold valves and make sure the vacuum valve and core removal tool ball valves are open. Start the pump. For cold weather starts, open the intake port until the pump reaches running speed and then close it off. You're now pulling a vacuum. It's important that the oil level remains steady when the pump is running for proper operation, about 1/2 to 5/8 up in the sight glass. If it falls too low, the vacuum pump could be damaged. If it's too high, it will increase the oil in the exhaust. Now connect the electronic vacuum gauge for accurate vacuum measurement, like this one from Yellow Jacket. The best place to measure vacuum is at the system, not at the pump. With a combination vacuum and charging valve on your core removal tool, you can attach the electronic vacuum gauge directly to the system and isolate it from the pump, hoses, and manifold for a true indication of the vacuum in the system. If you suspect an open or wet system, be sure to use the gas ballast feature on your vacuum pump. The gas ballast prevents water vapor from condensing in the vacuum pump oil by introducing a small amount of fresh air into the pumping chamber. Open the gas ballast just slightly and then begin to watch your electronic vacuum gauge. If the vacuum stays at a consistently high level of microns or doesn't pull down below 5,000 microns, your system still contains contamination or has a leak. Repair the leak before proceeding. A way to speed the vacuum process is to use a heat gun. This warms the molecules and gets them to leave the surface sooner, speeding the flow of vapor molecules to the pump. Remember to be careful because they do get hot and will take paint off systems. Once you've pulled a vacuum that meets the manufacturer's specifications, you can close the valves on the core removal tools. Observe the gauge. It's normal operation for a rise in microns to occur. This does not indicate a leak. However, if the rise continues to atmosphere, 760,000 microns, there is a leak in the system. Check the system manufacturer's recommendation for tolerance. Once you're satisfied with the reading, close the valve that connects the manifold to the pump. You can now shut off and disconnect the vacuum pump. Your evacuation process is complete, and you're ready for system charge. To charge, open the valve on the refrigerant cylinder. Add enough refrigerant to create a small positive pressure in the system. Just enough so it registers, or about 3 psi on the low side. You can now remove the electronic vacuum gauge and complete the charging process per the manufacturer's specifications. Once the charge is complete, you can replace the valve cores and remove the vacuum valve and core removal tools. It's a good idea to simply replace Schrader valves as they're not that expensive, and new valves will reduce the likelihood of system leaks. Screw them back in and seat them properly. Remove your tools and you're ready to go. Now let's go over a few quick tips on maintaining your vacuum pump. Before storing the pump, replace the fittings, ensuring the O-rings are in place. At this point, it's also best practice to inspect the oil. Most manufacturers suggest that you drain the oil after every use while the oil is still warm and replace with fresh oil, as contaminated oil simply will not pull down. To drain, first open the isolation valve to release the vacuum on the pump. Drain the oil and replace with fresh oil. Make sure to properly dispose of the used oil. Take care of your investment and change the oil every time you use the pump. It will only work as well as the quality and quantity of the oil it contains. The Yellow Jacket SuperEVAC pump shown in this video has a number of features that will help you evacuate a system more quickly and efficiently. The larger oil capacity of the Yellow Jacket SuperEVAC pump means fewer oil changes because you have more oil available to remove contaminants from the system. The large diameter oil fill port makes adding oil easy and minimizes the risk of making a mess. The oil drain plug with a large opening allows for quick oil drainage, which means you get your jobs done faster. The threads on the solid brass fittings are coarse to reduce the likelihood of stripping. Finger tight is all you need to keep the oil safely contained. The easy-to-read sight glass lets you gauge how full the pump is when you're adding oil. The vacuum gauge indicator gives you a general view of the vacuum being pulled. When it reaches the green zone, which corresponds to about 100,000 microns, you can begin relying on the more precise measurements of an electronic vacuum gauge. Also, it's a good indication of whether or not your system leak has been fixed. If you can't pull into the green range of the vacuum gauge indicator, your system still has a leak. A feature that's unique to this Yellow Jacket SuperEVAC vacuum pump is this gas ballast valve. When opened just a bit, loose enough to move slightly, a limited amount of air can enter the pump. This air helps exhaust water vapor instead of allowing it to mix with the vacuum pump oil, which is especially helpful during the early stages of evacuation when you're removing mostly water vapor. The isolation valve allows you to shut off, drain oil, and refill the pump without losing a great deal of vacuum, saving a lot of time when oil changes become necessary in the middle of a job. Finally, the exhaust fitting on this unit is sized for a garden hose attachment, so you can exhaust to the outside if necessary. Thanks for taking the time to learn more about evacuation and the tips you can use to be more effective on the job. We're glad you trust Yellow Jacket to provide you with the best tools and training to do your job right, and we hope you'll continue to turn to Yellow Jacket in the future. Thanks for viewing.